the Twitter check mark, except it's
Yeah, you have been verified. Yeah, yes, yes. Miss Rice verified. It'll be. I'm not even on Twitter. So whatever that is, yeah.
Is verified on any social media?
Yeah. I post pictures of my cats and my plants on Instagram. Approximately 3 people look at. I'm not telling you guys. So you can creep on my cats. They'll be like, "There's Miss Rice's cat. I've seen what her front door looks like." No. What? Oh, nice. It's a very nice one. My Instagram name is Miss Rice in the Flesh. I'm just kidding. That's no. No. No, because I am not crazy. I'm not trying, you guys. People would Instagram stalk me? No.
Miss Payne gives hers out though. Yeah, Miss Payne she does not follow anyone back.
I'm not actually gonna do it. I feel like I can find it.
Really?
No.
You'd find me and you'd be like, wow, that's a lot of plants. Oh, her cats are cute. That's all that would happen. No. No. It's wild. You're like, I can't even figure it out.
Give us some leads.
Character traits that are accurate of me. Crazy, smart, and cool.
Wait, crazy smart or crazy smart?
Crazy.
Do you follow any teachers at school?
No, I do not. I follow some people. I literally made it so like nobody can find me. I bet you can. I'm not telling you.
C-A-T-Y.
C-A-T-Y? No, yours is a K. I know yours is a K.
Why would I do that?
Because you know some teachers like they like wink.
That's very unprofessional.
I had a teacher in put her
But then I couldn't curse occasionally in my captions.
You should put your PayPal on campus.
But
Imagine how well that goes.
I just like to curse occasionally in my captions. And just a little HE double hockey sticks now and again when I'm feeling impassioned.
Did you ever watch My Cat from Hell show?
Whoa.
Sorry.
Ooh.
Oh, here's Dr. Davis.
Huh.
Terrifying.
Terrifying.
Yeah, Dr. Davis came into my 4th grade. And then she called me out.
Alright, how far did I get in the notes? I did. Okay, and did I, from my memory, I only did 1 over x, I didn't do 1 over x squared? Or did I do both? I did both. I did example 1, transformations, domain range, all that stuff. And then I did increasing and decreasing. Okay. And then I stopped at X and Y-intercept. Stopped there. Okay. So we do need our calculators out today. So let's grab those. You guys, I was multitasking while I was watering my plants last night. So I was like watering my plants and reading a book, and it took me 6 hours. 6 hours. I was watering plants, just what I was thinking. I was watering plants for 6 hours. At about hour 4, I was like, I gotta speed it up. This is taking forever.
Hour 4? That's when you bring a hose and you're just like...
Yeah. Like,
how long does it take?
No, so I have like a bucket with, you guys know the paint stir sticks? I like put those on top of the bucket and then I set the plant on top. And I like, cause because it's best if you pour water over the plant so that the water runs through the plant and goes through the drainage holes, because then the plant gets fully saturated, and that's how you build the best root systems. Okay? You don't go around and just squirt a little bit of water in each plant. That's fast. It is not good for the plant. You have bad looking plants after a while. So I put the plant on top of the bucket, I pour water, I let it go through the drainage holes, and I do that a couple times, let it drip for a little bit. So while I'm doing that, I just like read. That's not the most time efficient way to do something. I have like 75 plants. I watered almost all the plants last night. I kept getting distracted and doing other things like, oh, let me change my laundry. Oh, let me cuddle my cat for 30 minutes. Oh, let it... 6 hours. It took me 6 hours. Leca.
Yeah, do you have any of those?
I do not. But I'm gonna do some repotting soon, and I'm making my own soil mix this year, and it has worm castings. Do you know what that is? It's worm poop. Yeah. You can buy a 4-quart bag of worm poop for $12. So, okay, let's move on. All right, everyone has their calculators out. So, X-Intercept, Y-Intercept. All right, first thing we got to do is we got to graph this function. So, I'm going to clear this. Hitting the Y equals screen. If we want to clear everything, if we've been using our calculator in science class, or you borrowed one of my calculators, you don't know if the calculus students have been using it, we can do second plus 712. Clear everything. Okay. So y equals, I'm going to do alpha y equals, get my fractions going. 1 over 3 x plus 5 squared minus 2. Are we all good with plugging that in? Yes, yes? We're all good? Yes, yes. Oh, look at that. Look at that. Okay, okay. All right. So, do you guys want to scroll to find the x-intercepts, or do you want to just, like, tell the calculator, hey, looky here? Okay, so 1, 2, 3, 4, 5. So, it looks like it's between -5 and -4. Would you guys agree with that? Okay. So, I'm going to say look between -5 and -4. Okay. So, -4.592. Would you guys agree with that? Yes, Miss Rice? Okay, perfect. Five, 9, 2. And then the other one, 5. That looks like it's between -5 and -6. So I'm going to do left bound is -6, right bound is -5. -5.408. Okay. How did we feel about getting the X-intercept? Good? We got it. Okay, how do we find the Y-intercept? Well, Miss Rice first.
You calculate the value of 0.
Plug in 0. Now, if you don't like that it gave this to you as a fraction, the reason it will give it to you as a fraction is because we used the fraction option for like plugging in the function. So if it makes you uncomfortable that you're like plugging in numbers and getting fractions as outputs, what you can do is you can go to the y equals screen, and because it will consistently, if you plugged this in as a fraction, it will consistently give you fraction answers for every number you plug in. So if you don't want it to give you a fraction, you can go here and you can hit the math button and you can say option 2, take outputs, turn them into decimals. Yeah, which is kind of a neat thing. I learned that not very long ago, a couple years ago. Yeah, so you get right here. Let me delete this. You get right here, so you put your cursor at the very end. You hit the math button, and you go down to number 2, decimal. I hit the green button, alpha, y equals. Numerator over denominator. Yeah. Yeah. Yep. Okay. So now if we go back and do second trace, option number 1, plug in 0. Now it will take that number, and instead of giving you the fraction, it will give you the decimal. And I assume, I've never done it because I've never wanted the fraction output, but I assume that if you put a polynomial in there, something else that was not in fraction form, and you wanted your outputs to be fractions, you could do the same thing. You could plug in your function that was not in fraction form, and then put fraction on the end, and then all your outputs would be given to you in fractions instead of decimals, if it were possible. Assuming. Yeah. So, and the fraction answer was totally fine, but not very easy to graph. So a lot of times we don't want the fraction answer because we want to be able to graph that point. Yeah.
So there's like 2 X-intercepts. Is there ever 2 Y-intercepts?
No, because our calculator is always graphing functions, and so we're not going to see 2 Y-intercepts ever on our calculators.
That's like a single function.
Yeah. Now you can see 2 Y-intercepts on Desmos because Desmos will graph something that's not a function. It will graph like a circle. A circle could have 2 Y-intercepts because a circle is not a function. But a function has to pass the vertical line test where you can put your pencil across it and only touches one point at a time. And so if you're going to have 2 Y-intercepts, that's 2 points on top of each other at the same time. That's not a function. So if you ever graph something on a graphing calculator, it is only ever going to have one Y-intercept. And all the different functions that we have studied have been functions, right? So we studied quadratics, that's a type of function. We looked at the different parent functions. We talked about square root, cube root, cubic. Those are all different types of functions. We talked about piecewise functions. Anytime we use that word, they have to pass a vertical line test, which means they're only going to have one Y-intercept. Yeah, good question. Okay, let's flip to the next page. Continuity. Can you trace the curve with your finger, or do you have to pick up your finger to trace these? What do you guys notice about these pictures? You have to pick up your finger every time. So these are kind of piecewise functions could be continuous, but they were often not continuous. These rational functions are never continuous. You always have to pick up your finger. So this is kind of the unique exception to the functions that we've been studying, is that most of the functions we studied were continuous. This is the one function that never is, never ever, is always discontinuous somewhere because of those asymptotes that we have. You have to pick up your finger to hop over the asymptote. All right, so here we're going to say that we have this horizontal asymptote. The horizontal asymptote is always at y equals k. Right there, y equals k is the horizontal asymptote. So for this, we're going to say as x goes to negative infinity, as x goes to positive infinity. Can you guys tell which graph this would be? Is this a 1 over x graph, or is this a 1 over x squared? So 1 over x, you can tell because the curves are in opposite corners. That's what a 1 over x. You can look at those, but not typically until pre-cal. So we only do 1 over x squared because those are the simple ones. We're introducing you to rational functions kind of slowly, getting you the basics, and then in pre-cal you guys go wild with all the rational stuff. So as we look at the left arrow, what is the y value that you're seeing? Is the arrow going up, is it going down, or is it going to a specific number? Yeah, and what's that specific number? K. So we're going to say as you look at the left arrow, it's going to k. It's not going up, it's not going down, it's staying at the horizontal asymptote, which is k, whatever k is. It's the horizontal asymptote. And then as we look at the right arrow, is the right arrow going up or down, or is it staying at a specific number? Staying at k. So for these, since we were able to find the k value based on the equation, you can actually write the end behavior without even seeing the graph, because it's from the equation. It's the number on the end of the equation. So if it says like +5 on the end behavior is going to be going to 5. All right. The next one, similar idea, we still have y equals k is the horizontal asymptote. So we have as x goes to negative infinity, as x goes to positive infinity, and then for both of these, y goes to k. So they are boring and that the answers are always the same, but they are interesting and that they're different than all the units we've done before. Yeah. So different because this is the first time really that we've had it where the arrows are not going up and down ever. They're always going completely flat. Flat to the left, flat to the right. And this is the first time we've really seen it where we don't even have to look at a picture to determine it. We can just look at the equation. So that's kind of nice too. Okay, so when you guys look at the packet this time, you're going to be like, whoo, we feel like we have done these packets before because I go through and I change some of the numbers and I change what the equations look like, but you guys have done these transformations and characteristics packets. I do want to look at the first page together because I think that with the fractions, sometimes finding a stretch versus a compression can be kind of tricky. So I want to look at a few of those with you, but other than that, I think you guys are going to find this packet to be, pretty comfortable, pretty straightforward because you guys have done the characteristics a lot. So let me hand this out. We'll get started together. Okay, so if we look at this, can you guys pick out a problem where there might be a stretch or compression? Looking at the front page, can you pick out a problem? Okay. So what problem number might have something going on? 4. Okay. So if we look at number 4 and kind of compare it to the notes said that you're going to have something going on if you can kind of pull a number out and have that number times 1 over x minus h. Okay? So if we think about number 4 could be rewritten as 3 times 1 over x plus 9 squared. You could think of it, let me rewrite. You could write it as 3 over 1. Yep, you could write it as 3 over 1, if that makes it less confusing. So if it's 3 over 1, what is that? It's 3. So is it a stretch or compression? Stretch. Okay, so that's a vertical stretch. Okay. Now there's actually more than just number 4. Anybody see another one? Number 6. Yeah, number 6 has one. So if we were to take number 6 and rewrite it, we could say that we've got a negative 1/9 times 1 over x minus 3 plus 8. Okay, so what does number 6 have going on? Compression by 1/9. What else does it have going on as part of that 1/9? Yeah, it's got a reflection. It's got a reflection over the x-axis and a compression of 1/9. Okay. Do you guys see any more? Three has it as well. So if we look at 3, you could think of this one as 1 over 2 times 1 over x minus 0 plus 5. Does that make sense? So most people wouldn't write x minus 0. They would just write x. But if you want to put the 0 in there so you can think about it as having a left or a right movement so you can see it, then you could put the 0 in there. So what do we see with the 1 over 2? What does that mean? Yeah, compression. Compression by 1/2. Okay, so I just wanted to make sure you guys could see those because I think this is like, as far as vertical stretch or vertical compression, this is the least friendly function to be able to see it. Most students have a hard time seeing it. So it's a little bit easier if you think about pulling it out of the fraction so you can see it that way. Okay? All right, so go ahead, work on this. Answer key is in the back. It's kind of at the bottom because I haven't been taking down the answer keys from previous days. And then let me know if you see a little mistake on the answer key. I think they've mostly been caught, but there seems to always be one. Alrighty, we good? Yes, Miss Rice. Marvelous. So how could we approach the graphing problems? Yeah, you can look at your calculator. So I would always start by looking at my vertical asymptote and my horizontal asymptote because I can recognize those from the equation itself. And those are going to tell me where to look on my calculator. So what's the vertical asymptote? What's the horizontal asymptote for number 9? Okay, so vertical asymptote is going to be x equals -3. And the instructions are telling you to write these anyway and to draw them as well. So it's common practice with rational graphs to draw the asymptotes. So vertical asymptote at -3. So it's the opposite of the bottom number. And then horizontal asymptote at y equals 1. Okay, so then I would take this and plug this into my calculator. And now I know that -3 is my vertical asymptote, so when I look at the table on my calculator, I'm going to look to the left of -3 and I'm going to look to the right of -3 to get my points. So if you do second graph and look at your table, now I'm seeing everything as a fraction, so if I don't want everything as a fraction, what should I do? How do I fix that? So go to the end of my function, hit math, turn all these into decimals. Okay, so now I can go back and hit second graph. Now my table is going to be in decimal form. Okay, so I'm going to look at my table, error message, there's my asymptote, and then I can go just to the left a little bit, to the right a little bit, and then graph a few points, and then I'm good. I can graph it that way, okay? Another option is to copy down the points from the tables that I gave you guys in the notes and do the transformations by hand like I've shown you. So on your notes, you guys had it written out. You had the table said x and it said y. So -2, -1/2, -1, -1. 0 was undefined. That was the asymptote. 1, 1, 2, 1/2. So what you could do is you could say, okay, I've got the point -2, -1/2, -1, -1. X equals 0 is where my vertical asymptote would start before it's transformed anywhere else. That's where a parent function would have the vertical asymptote. And then I've got the point 1, 1, and the point 2, 1/2. and then I would take these as my starting values, and then I would do the transformations on them. So I would do my reflect over x. If I do the reflection over x, what happens to my points? The y-coordinates multiply by -1. So I'm going to take all these points, all the y-coordinates, and change their signs. I didn't leave a lot of room, so I'll go over here. All right. What's my next transformation? So we took care of the minus. What transformation do you guys see next? Or what two transformations do you guys see next? Left 3 and up 1. So if I take all my points and shift them to the left 3, I would have -5, -4. If this is x equals 0, would that be impacted by a left and right shift or an up and down shift? It's x equals something, left and right. So that's going to be impacted by the left 3. Left 3 would put that at -2, and then left 3 would put that at -1. Okay, and then if I go up 1 for this, that gives me 1.5. Up 1 for that gives me 2. Up 1 for that gives me 0. Up 1 for that gives me 0.5. So -5, 1.5, -4, 2, -3 I already graphed, -2, 0, -1.5. I'll give you guys some time to catch up. Does some of that seem familiar? Like, oh, we've done this before. We just have different points this time than we've had in the past. How did I describe an asymptote? What does an asymptote do? Yeah. So the curve gets really close to the asymptote. It's possible to cross one, but with simple functions it doesn't. So when you guys get to pre-calc, you're going to see functions that cross over asymptotes, but for our class, that doesn't happen. So we have these two little points right here. So once you have these two little points drawn, you're just going to connect them. And then I always think of it as looking like the smooth corner of a table. So it just kind of looks like this. It follows the asymptote up this way, and it follows the asymptote over here, and it just kind of looks like the corner of a table. So connect those points and then make it kind of smooth following the asymptotes. So if you needed to do it by hand, you could. The easiest way for you guys to do it is probably going to be to find the vertical asymptote in the calculator and then just graph a couple points. Because if you look, now let's look back at our calculators. If you look, 1.5, 2, 0.5. It's the same points from the calculator. So just locate that vertical asymptote and then do a couple points to the left, a couple points to the right. Does that make sense as far as the graphing goes? I think the graphing part is the hardest part of the worksheet. The rest of it is a lot more straightforward. Okay, any questions about anything that's expected today? We're good? Okay. I'm going to turn some music on, let you guys get started. Let me know if you have any questions. The answer key is on the back wall if you guys want to check any answers. And then I'm going to hand the quizzes out so you guys can see how you did. Sound good? We good? All right.